Hello everyone, how are you doing? This is going to be a video to help you review for your upcoming work samples, specifically algebra. So we've got a problem here called movie packages, and we're going to work on some of these skills. We're going to work on creating equations and two more variables to represent relationships between quantities and using graphs and equations on a coordinate axis. And then we're going to review solving systems of linear equations exactly and approximately using graphs and focusing on pairs of linear equations in two variables. These are high school algebra topics that you've learned and reviewed before, but we're just going to get a quick refresher for you. So here's our problem. The movie theater is offering a summer movie sale for students. You have two different packages that you could choose from below. Package 1. You could pay a one-time fee of $50. But then each movie you go to costs $4. You also have package 2. You can pay no fee, but every time you go to a movie, it costs $10. Now here's the problem. Depending on how many movies you plan on going to, which option would be the better buy? Use graphs, tables, or equations in your solution. So we need to use math. We need to think about, in terms of a work sample, all the different categories and answer this problem completely and thoroughly. So one of the things I'm going to start with, if it's algebra and if it's a problem, oftentimes I like to start with making a chart. Let's look for a pattern and see if we can go on here. Okay, so let's make a chart here on the top left. Let's say number of movies. I keep track of how many movies. And then we've got package number 1, how much it costs, and package number 2. I'm going to try and squeeze it in here, but I don't have a whole lot of room. Okay, so here we go. Let's go to, let's say I only go to one movie. So under package number 1, I'm going to pay $50. But if I only go to one movie, it's going to cost me $4 for that one movie. So it's going to cost me a total of $54. What about option 2? Option 2, I don't have a fee, but every time I go to a movie, it costs $10. So according to option 2, that's going to be the cheaper plan if I only go to one movie. Okay, but I'm looking kind of for a pattern. I need to be able to kind of articulate between any number of movies, 10, 20, 30, 25, 24. I'm trying to think big picture and use some algebra on this. So let's do a couple more. Let's do 2 movies and 3 movies. 2 movies is still $50 for flat fee, but then it's going to be another $8 for each movie. So that's going to be a total of $58. And if I go to 3 movies, it's a $50 flat fee plus 4 for 3 movies. So it's going to be a total of $62. And right now I can start to see some patterns. Every time I go up another movie, I add another $4. And so I can keep doing that pattern over and over. For package number 2, it's $10 per movie, right? So if I go to 2 movies, that's going to be $20. If I go to 3 movies, it's going to be $30. And I can see a pattern in this chart as well too. Every time I go to a movie, I add another $10. All right. So a chart helps me kind of visualize what's going on. And we can see, that's the word can, we can see the pattern in the chart. Again, if you're doing a work sample, this is showing your work. This is making sense of the problem. This is showing me that you understand that different packages cost different things and you're doing your work here. And you would want to show probably some work in terms of 54, 58, 62. How did we get those numbers? We took the $50. You would write this out, $50, and then every time it would movie, I added another 4. So this is 50 plus 4. This is 50 plus 2 times 4. This is 50 plus 3 times 4. And you want to show all that stuff and explain that stuff. That's good communication in work sample. Okay, so we got a chart. Let's use some algebraic equations. In package 1, we had a flat fee of $50, and the cost was equal to $50 plus 4 times however many movies, right? So let's make x equal, let's define our variables, x equal the number of movies we go to, and let's make y the cost, total cost. So for package number 1, the total cost was equal to my flat fee of $50, plus every time I went to a movie, it cost $4. So $4 per movie is 4 times X. So now I've got an equation relating this pattern for package number 1. And once I have an equation, there's all sorts of stuff I can do with it. Okay, let's find an equation for package number 2 here. So package 2, every time I go to a movie, there's no flat fee, so I'm not going to have anything in the beginning, but it's $10 per movie. So the equation for that one is the total cost equaled 10 times however many number of movies we went. Look at what we got. We have ourselves a system of linear equations. That's part of what we're going to, right? Solve systems of linear equations exactly and approximately. We have 2 different movie packages. Each one has a different equation. And part of what we want to know is, well, when is one movie package less expensive than the other one? Or is there a place where they switch? Is there a place where they flip-flop? Is there a place where they're the same? This is all the stuff I'm using my algebra and my math to try and do. So I've got a chart. I'm showing my work using a chart. I'm showing my work using an equation. I've defined my variables. This is all good stuff to have on the work sample. And now what I'm going to do is use my equations, and I can continue on with this chart and see if I can kind of find that place where one is better than the other. So let's go back to my chart here. I'm gonna have to kind of wind around a little bit to make it fit on the side. So let's do 4, 5, 6, 7, and 8 movies. I already know the pattern. The pattern for option 1 is to add 4 over and over again. So it's gonna be 62. This is gonna turn into $66, $70, $74, $78, and $82. Okay, so 8 movies cost $82 for option package 1. Let's keep doing for package 2. Package 2 was just 4 times 10, right? $10 for every movie, so 4 movies is gonna be $40. 5 movies is gonna be $50. 6 movies is gonna be $60, $70, $80, and look at that, they're getting pretty close, right? If I go to 8 movies, package 1 costs $82 and package 2 costs $80, so package 2 is still cheaper. But now let's look at 9 movies. When I go to 9 movies, let's see, package 1 is 82, I'm gonna add 4 more, so it turns into $86. But package 2 now costs $90. So what have we found now? We found right here that here's kind of the flip-flop, right? If I go to 8 movies, option 2 is still cheaper. But if I go to 9 movies, option 1 now, or package 1 is now the cheaper option. 86 is less than $90. If I keep going, that's kind of the flip-flop point of where to do it. So based on my chart, I could now answer this one. But let's do this as well with graphs, right? We also want to use systems of equations and use them exactly and approximately. So let's do a quick graph, and then we'll also do some substitution and solve this problem out as well. Okay, so for my graph, one nice thing about the chart is then these are all points that you can graph. So I'm going to go 0 movies, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's go all the way up to 12 movies. So right here is the number of movies. Again, I'm labeling my graph, the number of movies that I go to. And on the left here, let's put the cost. And we'll go from 0 up to, let's go to $100. So I'm kind of using my table, and right halfway would be $50. Now to graph a line, remember, I just need 2 points. So I'm going to graph this first one movie right here. So for option 1, that's going to make it my red line. Option 1 for one movie costs $54. So one movie, 54. We're going to start right there. But for option 1, let's go all the way to 12 movies. So if I went to 9, 10, 11, 12, I would keep adding 4. So 90, 94, 98. 12 movies would cost 98 bucks. So let's make that other dot. So 12 movies is going to cost me 98, which is just under 100. Oh, I just realized it's off of the square. I'll kind of graph it so you can still see the line. But it would be kind of like this. Actually, so we have 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 right there. And let's plot 8. So 8 would get up to 80. So it'll be right about like there. Once you have 2 points, we can make a line. All right, so there's option 1. Now let's graph option 2. Option 2 we had in green, so let's make green. Option 2 at one movie was $10. So let's go up one movie, and $10 is right about there. We can definitely see it's less expensive. And then for option 8, it went all the way up to 80 as well. So 8 and 80, it's just a smidge less than the 82 for option 1. And so let's graph those. And you can see option 2 is less expensive for the total cost, but it's catching up. And then even on the graph, I can see that there's a place where they crisscross right around 8.5, kind of right around there. We call that the solution for linear system. That's the place where my two lines intersect. And it matches up with kind of right in here somewhere, this place where both plans would be the same. I don't have it calculated on my table, but I could kind of see where that place would be on my graph, the place where they intersect. Okay, last thing I want to do is let's solve this using algebraically. We'll do this exactly. We'll get our exact value, but we'll match it up with our graph and our table, and we'll do this equation. So substitution. If both of these are equal to y, I can substitute what y equals, the 10x, in place of the other y. So I can write a new equation, 10 times x equals 50 plus 4x. I want to know, when are the plans the same? When is option B, package 2 equal to package 1? So let's solve this out for x now using our algebra. So I want to get x by itself. I'm going to subtract 4x from both sides. 10x minus 4x is 6x equals 50. Going to divide both sides by 6 to get x by itself. And 6 goes into 50 8 times with a remainder of 2. So 8 and 2, 6 turns into 8 and 1/3. So what does that mean? That means if I went to 8 and 1/3 movies, that would be when the prices are the same. Now I can't go to 8 and 1/3 movie. I can go to 8 movies or 9 movies. So that's kind of, again, getting into the context, but this would be the exact answer, is 8 and 1/3 would be the exact x value of where my two lines intersect. So we got that x value. Now let's figure out what the cost would be. We kind of want to play around with cost and value, right? So if I know x is 8 1/3, I can go back to my equation. Let's use the bottom one. And it says my y value, the cost, is equal to 10 times x. So 10 times 8 1/3 is going to be 80, plus 10 times 1/3 will be 83.3. It's going to be 83.3. So again, not an 83 1/3. So not an exact value again, but that would be the cost. So there's the cost if I go to this many movies, and that's when the cost is the same for both packages. So that's my solution. There's, again, a pair of solutions. This is where they intersect. And so if I go to 8 movies or less, package 2 is going to be the better plan. If I go to 9 movies or more, package 1 becomes the better plan. And so now I can write out my answer. I've got all my math and I've shown my work. And hopefully that gives you a good review on how we can use equations, tables, and graphs to help see and understand problems when you're comparing two different things like this.